Yeah, all right. I'll start with the session now. So I welcome you all to this webinar, Modeling, Analysis and Design of PSC Box Girder Bridges. So myself, Master Akshay Magar. I'm a structural engineer here at MIDAS IT. Okay, I'll just start with the session now. Yeah. So so today we'll be dealing with this complete analysis, modeling and design of this box girder bridges. Since due to urbanization there has been a lot of requirement in the viaducts as respect to the section shape and as well as the requirement of the simply supported spans. Okay, so in order to throw the light, so we'll be dealing with how we can cope up with such need with the growing demand of the requirement of the bridges. Okay, so for that, as being said, the PSC box or the box section being most common used sections in the viaducts. So today we'll just consider with a typical example to with the complete right from modeling to the design part. So we'll be dealing with completely with the IRC design code, and we'll be saying the application of the load and everything right from modeling. Okay. So yeah, so my webinar presentation will follow as such. So I will first of all give you the introduction, then we'll deal about the load calculations, how are all the different load which we need to calculate, as well as we need to apply those onto the structure. Then we'll see about the model generation, how we can quickly create the structural geometry just with the simpler definitions of extrude and translate. Then we'll deal about the analysis and interpretation part. And finally, we move on more towards the design aspects. So yeah, so talking about the metro viaducts, so as could be checked, so these are all the box structures. I just specifically took to represent these images. So with the growing need, so it could be checked, the structure could be either, it could be a straight one or the geometry could be in a curved position. So with this such requirement, it comes with the various construction stages or various construction definitions that could be simulated. So as per that, this could be seen, these are the simply supported box girder bridges. So it's completely largely used in the metro viaducts. So the necessity being as such, so they are mostly used in metros just for the reason as continuous welded rails, they provide a very good comfort for the passengers. So that is why they have been designed as such. So we'll be today dealing with such structures, so how we can quickly generate such particular geometries, whether apart from the modeling and design capabilities. Yeah, so these are few of the examples. Then yeah, talking about the construction methodologies, generally the box girder bridges, either they are segmental, like they are the precasted at a site and they have been transported and they have been placed in position with the help of the launching girder, right? So they are just based on the segmental construction. Then the second comes down are your balanced construction bridges, so what we call as free cantilever bridges. So that is again the one of the methodology where your casting starts from the pier and it end up with the end segments. So this is about the balanced cantilever constructions. And third is your the other casting sequences such as your incremental launching method or the full staging method. So the construction methodology differs as the sequence, right? So today we'll be dealing with this segmental construction, how we can do that. Right? We'll be seeing in how that could be implemented with the help of the construction stage analysis. Coming next. So in this section, we'll be using the following section geometries. So one would be your mid section, second would be a support section, and third is your diaphragm section. Okay. So also we will try to see how we can quickly generate such section geometries, right? I think there are some issues. So for those who are not able to listen, so let me know who is not able to listen. Am I audible to everyone? Yeah. Yeah. So okay. All right. Yeah, so sorry for the technical inconvenience. So I think there was some issue with the audio. Okay, so let me move ahead. Okay, so this will be our longitudinal section detail of a bridge, which we'll be considering for today. So in that, for those who are not able to get the audio, kindly make ensure that you are connected to either microphone or the headphone, right? So that you can listen. Make ensure that it is connected. Yeah, so this, sorry, again. Yeah, so this would be a longitudinal section geometry which you would be considering. So over here, we have a cantilever slab. Then we have the diaphragm section, then which is of 1.125 meter. Then again, we have next is the support section, which is of 3.1 meter. Then we have the transition section, that is our tapered section definition. And third, we have the mid-section geometry as discussed. Okay. So this will be our typical longitudinal configuration of the bridge which we'll be dealing today. Just for a simple case. Okay, so now moving towards the segmental constructions. Okay, so mostly the major construction activities that are being highlighted below. So first, it would be a precast segments. Okay, so as discussed, these are nothing but the precasted segments which are casted at a site and that have been transported and launched with the help of launching girders in place. Then second is your substructure, which will include your foundation, pier and the pier cap erection. So once your substructure is completed, the segment would be launched, right? So that counts the erection of the segments. So the segments are being erected once your substructure have been undergone certain maturity. So you can directly go with the launching girder system where each segment will be cast one by one with the help of the lifting segments, right? Then after that, they have been joined with the help of glue. So that there might be requirement that the temporary pre-stressing could be done. Yeah, so the temporary pre-stressing could be done at that point, and similarly, there can be stick with the help of the glue, or the segment alignment could be done. And fifth, you can go with the final post-tensioning. So you can just, if it is a post-tension girder, then you can just go with the installation of the cables into the ducts, and similarly that can be pre-stressed. And the last construction activity would be related to your finishing of the total structure, such as installation of your SIDL loads, such as your crash barrier or the casting of the seismic arrestor or the other works which are required. Okay, so such would be the typical segmental construction if you talk about. So this is these are all the precast segments. So they have been casted at a site, right? So once you are all the substructure has been erected, so now the segment could be launched one by one with the help of your launching girder. Then one by one, and the temporary pre-stressing can be done. So once all the segments are casted at a single go, then they can be very well pre-stressed with the help in a single go for simply supported spans. Okay, so now let me take you through the modeling demonstration part. So just open the software. Okay. So now most of you will be might have used this particular program. So I believe you might have certain idea about the interface. So I'll just quickly give you the glimpse of the interface. So you have the very first command, that is your civil icon, so which is majorly dealing with the import export feature. So if you're working with the other programs as well, so you can import those particular files such as your AutoCAD, SAP and Lucas file that could be directly imported. The second option is to export. So you can export into this input file called MCT file. Okay. So now if you talk about the commands, so they are all streamlined in a modeling workflow. So as the engineer proceeds with the modeling, analysis and design, so they are all arranged in the engineer's point of view. So if you talk, this is wave, this structure, you have a node element, you have a properties tab. So these are all streamlined in a modeling workflow. So in the view tab, you will find all the various basic viewing options. Okay, such as your dynamic view options you have, then you have various selections options that are available, then you have the activities tab and the window tab that are available in the view tab. Then you have majorly the structure tab, so wherein you can set the structure type or the type of analysis to be set in. Then coming to the wizards, so as could be talked, so there are various types of wizards that have been integrated right from to deal with your conventional types of bridges to your segmental constructions, such as your if you talk about the conventional wizard, you have the RC slab, RC box culvert wizard. So the main aim of wizard is to quickly generate your geometry with the standard modules that have been there. So you can quickly fill in data for all the entire structure within in the same window, such as if you talk about this RC slab bridge wizard. So you can enter all the longitudinal configuration, transverse configuration and the load data in a single tab itself. Okay. So once you enter this, a complete model or a 3D geometry could be directly generated by the program, so which you can directly edit at any point of time based on the requirement. So this will be very helpful when you try to generate a complex geometry. So it will also save your valuable modeling time. So coming to this, again, you have the RC box culvert wizard as well. So dealing about the segmental bridges, so you have various such as your barrels and on similar lines, the wizards have been formulated based on the method of construction. As the segmental construction, you have the FSM as well as the ILM bridges or the MSS bridges. So talking about the advanced bridges or the complex bridges, we have the suspension as a cable stayed or the extra dose bridges that could be very well the geometry could be very well generated using the wizard. Similar lines, we have the steel composite and the PSC bridges, right? So under the node element tab, again you will find the various tracing functions like to generate your geometry. Then you have the properties wherein your time dependent material properties and the section properties could be defined. And you have the boundary tab, so wherein you can constrain the various supports using 3D boundary conditions. Right. Then you have the load tab, so you can assign your load right from your static to various dynamic and the construction stage load that could be assigned. Then you have the analysis tab, then the results, that is for your final interpretation part. You have the PSC tab, that is dedicated for your PSC design. And finally, you have the design part that you can design with the RC or the composite design. Right? So with that, these are the various tabs that I have just given you the glimpse. And this is your complete model window where actually your model will be created. And in the left side, you will find this tree menu. So basically the tree menu is the important one where you will be dealing with all the important definitions that you have performed. So you have the table, works tab. So under the works tab, all the definition that you have worked out will be defined under this particular window. And finally, this is the message window where you will be getting all the error and the analysis messages. So now let me try to take an example for today. So this will be the typical example which we'll be taking. So we'll consider with the single span geometry of 40 meter length. Okay, so width being 8.5 meter in the transverse direction. Okay, so we'll be dealing with this IRC 112. Okay, for your design code, which we'll be seeing today. So let me try to start with this. Okay, so first of all, we'll try to define with the material properties. So I'll just go to this properties tab. I will go to material properties and go click on add. Okay, so over here you can set the material which you need to define. So over here you can directly choose with the concrete, right? So once you click on concrete, this particular tab will be enabled. So wherein we can very easily choose from the code, any of the standard codes which you wish to. So I'm just choosing with the IRC. I'll just choose IRC, and over here I'll just give the grade as M40 for the girder. So over here you can give the name as per your requirement. Right. So now once you define this, so you can click on apply, hit on apply. Then the second material you can add for your that is for your steel. So likewise you can go on adding the standard and the grade directly. So here you can let me choose the Indian standard, and I will just choose over here as FE540, right? So I'll add up these two material over here. Yeah. So I'll also save this particular file. We'll save this. Yeah. So once it is saved, it will be auto saved. All right. So the material property definition is quite simple. Over here you just have to choose the design. You just have to give the standard, and you can choose from the standard grade of steel or concrete. All right. So this is about the material. Now we'll move towards the section definition. So we can go to properties tab, and over here you can directly go to section definition, that is your section properties. Okay, so I will click on add. So now if you come to this section data, over here there are various section library that to choose in. So you have database user tab where you can directly select with the different types of sections available. Then you have the value type of sections also, right? So now I will directly come to PSC tab. So in the PSC option, you have a wide variety of sections that are there. Like you have one cell, two cell, or the IS sections that are there. So once you choose any of this shape, so either it is a PSC one cell, you can directly enter the dimensions by looking at the bitmap images. So you can just try to input all these dimensions accordingly. You can also guide your sections by making your joint on and off, so that you can do it just to guide if there are a lot of if you wanted to introduce more haunches into your girder section, then you can accordingly turn that particular joints on and off, so that you will be able to enter these particular dimensions, right? So it's take times to enter all these dimensions. So I will just try to quickly import the sections directly from the other file section, so that will save our time. Yeah. So now I have just imported the various sections, such as your mid section, and you have the support sections, then you have a diaphragm sections and the taper sections. Just show you how this could be defined. Yeah. So now this is particularly for your mid section geometry, right? So now, yeah, when you talk about the mid section, sorry, when you talk about the tapered section definition, over here you can very well go to this taper tab. So once you have already defined this particular mid and support section, so you no need to again redefine those in the taper tab. Over here what could be done is you can directly import those section geometry considering your I-10 geometry and your J-10 geometry as directly. So program will automatically consider or automatically create your variation of the tapering, either it is a linear or parabolic one as per the given input, right? So this is how we can create with the sorry section geometries. Yeah. So now after that we'll be going with the yeah. So these are all the geometries that are there. We have the support, and we sorry, the mid section geometry, then we have the support section geometry and the diaphragm geometry, right? So those I have already done with the example. So I have directly imported those. So in order to cover up many things, so I have just quickly defined those and I imported directly. All right. So now I'll move towards the definition of the time-dependent material properties, right? So the time-dependent material, as we know, for the segmental construction bridges, so they are undergo. So let's say if you have a 2-span or a 3-span bridges, so when you talk about the first span construction, so we need to consider the time-dependent effect of creep and shrinkage and the compressive strength onto the structure, right? So since if first span is casted, it will undergo certain creep and shrinkage deformation prior to the second one, right? So in order to account those, as well as in order to calculate all your time dependent losses, we can directly consider with the help of this particular construction stage definition, for which the time dependent material properties are required with, right? So you can directly go to this creep shrinkage definition. Over here you can click on add. So now here you can give the name as M40. Over here I can directly select with the Indian code, or else you can also go with IRC. Yeah. Here you can enter this compressive strength of concrete. Relative humidity you can enter. Now you can enter the notional size, the preliminary notional size you can enter. Later on you can change it. So once you input the prerequisite data which is required as per the code, then you can hit on this show results. So program will calculate all your creep coefficient and the shrinkage strain values for the respective start loading and the end loading. So once you define any of the intermediate state, the program will automatically consider those parameters accordingly, right? So this is how we can define with the time dependent material properties effect. So I will just add up one property. Secondly, I will just go on defining for your compressive strength. I'll click on add. So this is how we can define for creep shrinkage. Secondly, I'm adding for your compressive strength. So I will give over here as M40. Okay. And choose IRC 112 again, where you can directly enter the mean compressive strength value. Right. Again, the type of cement you can set, and you can just return retograph. So this is for your particularly for your compressive strength definition. So I'll hit on close. Now we'll link this particular two material properties to the material. So you can directly select those particular property for your earlier defined for creep shrinkage and the compressive strength to the concrete material. So directly it doesn't understand how that two particular properties are related to which material. So we need to manually enter using this particular material link option. So I'll hit on add. So I'll close this, right? So now as could be checked. So yeah, so now we have completed till the material and the section definition, right? So now we'll move towards the definition for your modeling part. Okay. So in the modeling, we can directly discuss about this different methodologies to adopt. Okay. So when you talk about the modeling, either the conventional method you can go is to create a node and then translate and create the intermediate elements, right? So this is again a time-taking task. So with these options that are available, like with the extrude command, we'll be directly generating the line element with the help of the node. So that's what extrude command will help us out to quickly generate an entire model. Okay. So we'll just try to define a node first of all initially. So these are various tracings options that are available, right? Then you can just quickly create a node out of it. Yeah. So I'll click on add. Okay. So talking about the reference axis. So this is the global x-axis. This is the global y, and vertical is global z in MIDAS. It follows. Okay. So we'll be following these directions as for now. Okay. So this is also, there are certain viewing or the shortcut command keys that are available. Okay, so either if you are not very well compatible, then you can also check it from the view tab. Okay, so these are various viewpoints that are available. So if you go to view tab, so there ISO view, top view, bottom view. So accordingly you can switch or navigate between the different views. Okay, all right. So coming to the modeling part. So over here you can quickly create a node over here. All right. So why I have created a single node? So I will explain that. So just because to extrude a line element out of it, so there is a requirement to have a node priorly. So now I will quickly go to this extrude tab. Okay, under the elements tab you will find this extrude command. Yeah. So now in the extrude tab you have the extrude feature wherein you can directly create a line element right from the node. So if you are going for a plate model, then you need to have the line element defined priorly. If you are going for a solid modeling, then you need to have the planar element. So this is how the extrude command works. So that is the reason, in order to create a complete line element, I have defined a single node over here, right? So I'll just select a node. I'll just select the element type to be beam. So this is the wide library which we have. Okay, so all right, so I will just show you what are all the different element libraries which we have. Okay, so I'll just go to this create element. Yeah. So in the element type, if you observe, so this is all the library which we have for all the finite element formulation that is there. So first is your truss formulation, then again you have the tension formulation, compression only elements. Again you have the general and the tapered beam, plate elements or the plane stress or the plane strain formulations, as well as the solid model. Right. So this is the library which MIDAS has. So I'll just continue with the extrude command now. Okay. So now I'll just choose with the general beam and the tapered beam option. Yeah. So now over here you can directly give, you can directly give the material and the section assignment directly when you are trying to generate your geometry. So I'm just choosing a mid section directly in order to extrude your complete section. Over here also I'm choosing the material property to be girder, which I have defined previously, the girder property. Right. Now over here, coming to the translation, either you can specify the equal distances or you can directly specify with the help of unequal distances. So in our case, we have seen the geometry to be as such, like we have a 0.5 meter diaphragm section. Let me try to open the presentation part. Yeah, so yeah, over here, we try to focus this. Okay, so my translation will be as such. We have a 0.5 meter cantilever slab here, and we have a diaphragm section, and we have a support section, and we have a tapered section. All right, and then the mid section. So we'll just follow as such. Okay, so we'll divide the 40 meter, entire 40 meter. Okay, accordingly. So I'll just use this unequal distance for the same. Okay, so I'll just input the dimension as such. Okay, so I am just choosing the axis to be x-axis. So I'm inputting the dimensions here directly. So I'm just entering the first diaphragm section, that is your 0.5 meter diaphragm section, into two parts. I'm just trying to divide the line element. And next 39 meter I'm trying to divide at a distance of 1 meter. So that is how we are doing, like 2 at the rate 0.25. So prefix will specify the number of elements and suffix will denote the distance. Again, for the simplicity, I will again add up the diaphragm section. Okay. So I will just select the particular element to be extracted. So I'll just select that particular node. So I'll just hit on apply. Okay. Alright, so now what I have did is, with the single section geometry I have completed, I have just directly generated the entire structure, right? Just to quickly get my geometry done. Okay, so I can just navigate to different views also. Alright, so now with the help of the tree command, that is the tree menu, I can just go on changing the sections geometry as per the requirement. Okay. So now I can just select with the end sections, that is your diaphragm section. So I can go to this view tab. Over here there are various selections options that are available. So I can use by select single, I would select by window option. So I'm just using the select single option. So I'm just selecting the end sections, end elements, so which is of 0.5 meter. Now I can directly drag and drop the diaphragm geometry from the tree menu to your model window, right? So accordingly, automatically the section geometry will get changed, right? Similarly, I can go on changing with the rest of the geometry. Okay, so I assume that it's again 3 meter, next 3 meter. So I have divided into the equal divisions, right? I can directly select with the elements, right? All right. So now this is your support sections. Again, following the similar stage, either you can also right click and make it assign, or you can directly drag and drop into the model window. So automatically those particular geometry will get assigned. And third, you have the tapering sections that are there. So you can select those tapering sections. Okay. So this is the geometry where you have the change of from the support to mid, right? So accordingly, you can import this support to mid geometry. So over here also, again, you have the change of section of geometry from your mid section to the end section. So I can directly import the mid and move to support geometry from the tree menu, right? So now this will again denote that all the sections. This is your mid section. Okay. So this is your support section that is highlighted. If I double click on this, so those will be highlighted. You have the diaphragm section and your tapering sections definitions that are there, right? Yeah. So this is about your section generation. Okay. So now let's try to create the support nodes or the support geometry for the same, right? So since if you observe, so there are no support nodes that are available over here. So we'll just try to create the additional nodes below. So I can again use with the different options available. Like if you go to node element tab, either you have this create node options wherein you can directly input the coordinates itself if you have worked out the coordinates, or else you can also use this translate command. Okay, so you can use this translate command for the same as well. All right, so I will just go with this translate command for the easyability, right? So I just translate the selected nodes to be translated at the ends. So I'll just use this node. Okay. So I'm just trying to translate the nodes at the mid, bottom section. So I selected this end nodes, right? So I'll translate at wherever my bearing locations is there. So I'll try to focus. I'll just try to show you this bearing orientation. Okay. Okay, so this would be our typical bearing configuration that which we have. So which will follow today for the same. We have a 1.9 meter eccentricity from the center line. So we'll translate or create the top and the bottom bearing nodes for the same. Okay. So here, yeah, again coming down. So it is 1.9 meter from the center line. So you can translate the nodes accordingly at that particular position. So you can enter this as minus 1.9, and in the Z direction, I'm entering minus 3. So I'll click on apply. So that one node will get created at this particular position. Right. So once again, I need to transfer that the positive directions as well. So I can use this previous selection command. So that previous selection command will help you out to avoid again the same selection. So you can also go to this, or you have the select previous option available over here. So you can use this select previous command. Right. So now you can just turn this to positive, so that you just need to translate those at this particular position. So you can click on apply. Right. So I have translated from both the position, the bottom nodes. Right. Right. So these are my top bearing nodes which I have created. Then now I'll be creating with the bottom bearing nodes. Again with the similar function or similar tab, I can use this translate node option to generate my bottom bearing nodes. So I just keep yeah. So I just keep the depth of bearing to be let's assume the depth of bearing to be 100 centimeter, sorry, 0.1 meter, let's say 0.1 meter. I'm just entering this as 0 minus 0.1. Okay, so I'll click on apply. Okay, so I'm just assuming to be that depth of bearing that I have assumed. Okay, so now I have just created a geometry with the elements and nodes itself. Okay, so over here you can see this. This is the top elemental node, and these are the bottom nodes which I have created. So if I turn on this hidden view or the 3D view, so this is my finite element definition which I have given. This is your line beam element, and bottom are your nodes, right? So if you observe, there is no physical connection between these nodes. Okay, so we need to provide the connectivity from your top bearing nodes, sorry, your top line element to the bearing nodes, right? So as to cause your force transfer. So we'll be joining this particular links, we'll be joining these particular points using the rigid links, and we'll be formulating the elastic links in order to simulate your bearings, depending on the type of bearings which we have. Okay, so we'll just try to go with the boundary definition now. So just go to boundary tab. Over here, you can go to this rigid link. Okay, with that, yeah. So priorly, for the construction stage analysis, we will be requiring with the different group definitions. So we'll try to see how we can create with the groups. Okay, so we can directly come to groups tab. So we have different groups, like we have the structure group, we have the boundary group, and we have the load group. So this is particularly for your carrying out your construction stage analysis, where we'll be activating and deactivating different parts of the structure with respect to the structure group. Then we have various supports in terms of final support, elastic links, and the rigid links, which again we'll be specifying with the help of boundary group. So and thirdly, we have different loads that have been acting. So it's the stage load or the construction stage load which are acting. So that will be categorizing with the same. So first, initially we'll just try to make the different groups or the structure and boundary and the load groups. So let me try to create a new one. So I'm just giving the name over here as structure. That's the structure. Then again you have a boundary group. Let's say you have a rigid link. Or else you can use this new 3-dot button to generate quickly. So again you have the elastic link. We'll add up one again, and the final supports. I'll add up this. Okay. So I'll close this. So I've added one structure group and I have added with the boundary groups. So I'll later on explain what is the significance of creating this group when I come down to construction stage analysis definition. Okay. So right now we have just categorized into different structural groups. Now let's go towards definition for your geometry, that is your boundary condition. Okay. So now our boundary definition would be as such. So we will be creating this particular top element with the help of the rigid links. So we'll go to the rigid links. Over here you can just select as rigid link. You can give the boundary group as rigid link, since we'll be activating that into the stages. So we need to activate them accordingly. So that is the reason why I have given specifically the boundary group name as rigid link. Okay. Now over here you can specify the master-slave connection, that is your master node and slave node definition you can give. Okay. Now over here you can choose the master node. So the top line element I'm choosing as my master node. So let me turn on this node number. Yeah. So that node number 2. So the node number 2 will be my master node. So I'll just click over here. I'll just select node number 2. Right. And now you can just use this rigid body, since I'm going to constrain all the degrees of freedom, so that it can have a complete rigid action at the end. Similarly, once you are trying to give a master-slave connection over here, you can also use, in order to avoid the repetitive tasks, you can use this copy rigid link feature, wherein you directly specify the distances and the direction accordingly where that rigid link needs to be copied. So I'm just specifying over here as 39.5 in X direction. So in the X direction, it will get copied once I have activated at this particular point. So now once you have specified the master node number and constrained all the degrees of freedom, you can directly select with the slave nodes. So the slave nodes are nothing but my top bearing node elements. So I can directly use this selections options. So you can use this select single, the select single or select by window you can use, and you can use this top bearing node for your selection. Right? So once you have selected this, so you can hit on apply. So now automatically the rigid link will be constrained right from your top line element to the top bearing nodes. Similarly, at this particular position, it will get copied once you use this copy rigid link feature. All right. So this is to induce the rigidity at the end, since there is no connection. So we have created the rigid link for the same wherever you have the support definition. Right. So now let's move towards the definition for your supports. That is for your simulation of your bearings. Okay. All right. So we can quickly move towards the bearing. We can come to boundary tab. So over here, now once we have already done this, created a connection between this, now we will be creating the rigid links in between. Sorry, the elastic links in between in order to simulate the bearings. So I can go to elastic link. Over here, I can choose elastic link, the boundary group name which I am choosing. And again, there are different types of rigid link that could be provided. So you have either the elastic type of rigid link or the general link. So general link is basically wherein you can directly simulate the actual stiffnesses. Okay. For your geometry creation, like depending upon the type of bearing, you can very well assign the stiffness values. So if you talk about the stiffness to be entered, so there has to be entered in the local direction of the elastic link. Yeah, over here, if you check, there are different boundary groups which I have created. Just in order to categorize them, I have created the boundary group. One for your rigid link, second is for your elastic link, that is for your this definition, and third is your for your final supports. Okay, so this is how it will go for your boundary groups. Okay, this is for your boundaries. Yet we need to assign certain load groups as well. So over here, entering the stiffness values again, you need to enter them accordingly. Let's say I'm assuming a fixed free condition. Okay. So accordingly, you can constrain those degrees. Accordingly, you can restrain those translation stiffness or the rotational stiffness directly. Right. So now I'm going to enter the translation stiffness of very high magnitude. Let's say 10 to the e power 6. Right. So in this in all the direction, I'm constraining the all the X, Y, and Z, that is the degree of translation or the stiffness of in that particular direction to be restrained, right? So just by entering the very high stiffness value, I'm just trying to simulate my bearings as free condition, fixed condition, right? So once you give over here, you can directly use these two node options. With the help of the two node, you can directly select with the first point and the second point, right? Similarly, over here also you can just specify with the two nodes. Okay, so you can also use this copy elastic link option once if you wanted to copy into the either directions. Right. All right. So now let's take an example. This is a fixed one I am considering. Now let's say you have a axially guided or you have a transversely guided bearing. Now you can just release or you can assign a minimum stiffness into that direction. Right. So if you check, so my elastic links are being assigned in the vertical plane. It means that my local of the elastic link into the is in the vertical direction. So it means that this is my SDX, which I need to be carefully entered, right? So this will follow my vertical stiffness, this will follow my transverse stiffness, and this will follow my longitudinal stiffness as per the right hand thumb rule, right? Then next is your free bearings. So let's say you want to only restrain into the vertical direction. So I will just keep SDX to be restrained and I will just release into the other direction, that is Y. So just by assigning the minimum stiffness values. So here you can assign the minimum stiffness values. So I'm just assigning this, right? So this is how I will be assigning the supports or the elastic link at the ends from the either end. So I'll just change the view from this particular viewing options. So again, I will use this two node option to generate or create my elastic links. Okay. So I'll just navigate to my isometric view again. All right. So this is how you can create with the different supports for your elastic links. Right. All right. So now let's move towards the supports. Right. The final supports. If you now we have just created this with the rigid and this has elastic link. Now my final girder is resting onto the supports. Now bearings are resting onto the pedestal. We assume that. So we just go to define supports tab. Over here you can just again select with the boundary group, that is your supports. And now you can quickly set in the degrees of translation. You can quickly restrain the degrees of translation, that is denoted against dx, dy and dz, and r refers to your degrees of rotation in x, y and z again. So you can just restrain them accordingly. So I'm just trying to give them as fixed for all the support bottom nodes. So again with the selections I'm just selecting the bottom nodes. So I just hit on apply. Okay. So this will assign the support conditions at the bottom where my structure is supported directly onto the pedestal through bearings. All right. So this is all about the boundary definitions. All right. So now let's move towards the loading part or the loading definition. Okay. Again, on the similar lines which I have created for the groups, I can just go on creating for your different load groups. So initially I have created with the boundary group itself, right? I'll just create with the load group. So I can just add up this. So I'll add up this few of the load definitions. That is your self-weight. So I'll quickly add this. Then you have the superimposed dead load. I'll add up this again. Again for the that is for your SITL, I'll categorize into one. Okay. Then you have the pre-stressing loads. That is the pre-stressing strands. You have different pre-stressing strands you have. So accordingly, you can give the name over here as pre-stressing load or the pre-stress load. So if you have the number of cables, accordingly you can try to simulate the cables. So let me try to give the pre-stressing into the 4 stages. So since I'll assume that there are 4 level of tendons that are being defined. So that is the reason why I have created 4 different groups for the pre-stressing. Alright. Alright, so you just close this. Now let me try to go to create view of the load cases. So I'll just go to loads. Over here, you can just try to first of all initially create with certain cases, that is your static load cases. Then over here you can give, let's say for self-weight. Then you can add up here as construction stage load. So since the type has to be construction stage load itself, since it's being activated into the stages, so that the load type has to be specifically construction stage load. And click on add. Then you have the second your SIDL load, that is your superimposed dead load for your, let's say for bearing course. So I'm indicating as SIDL WC. Again, the type has to be same. You click on add. Again, third you have for your crash barrier. So I'll click on add again. And finally is the pre-stress load. So click on add. So I can also add a first temperature cases. So you can also add the temperature load. So let me try to create few of the temperature load cases. Let's say for temperature rise. So we can click on add, again fall. So likewise you have to go on creating with the cases. Again for the gradient as well. You have to add up with just you have to change the type. So we can click on add. So likewise you need to create with the different cases over here. Right. So now once you have created the cases, now you can go with the assignment of the loads. So first initially is the self-weight. So you can directly go to self-weight, where you can just choose the load class as self-weight and load group to be self-weight. Right. And now you can assign the factor over here as, let's say I'm assigning the gravity direction as -1. So I'll hit on add. Okay. I'll close this. Now second is your load for your superimposed dead loads. Okay. So you can, that could be assigned as an elemental loads. So you can directly go to element beam loads. Now you can add up those one by one. So we'll try to add up one SIDL bearing course. Okay, so again you can just categorize them into a single SIDL load group. Now here you can assign the type of load to be uniform loads again. So there are various types of load, like you can assign the uniform pressure, the trapezoidal loads, or the concentrated forces, or the concentrated moment that could be chosen from the load type. So I'm just using this as uniform loads. Now if you have the eccentricity, you can assign the eccentricity. If not, then you can directly give at the line element definition. So direction of the application you need to set it. So I'm applying into the global Z direction. Let's say you need to calculate those. Accordingly, you need to make the load calculation for the same, right? If you all right, so I just forgot this. So let me take you back to the slides. So magnitude of the loads that have been there, which we need to arrive initially. Okay, so there are like dead loads we have, like whatever the dead load of the structure as well as the superimposed dead load that we have, and then we'll be coming to the live load definition. Secondly, again we have the various temperature load. Again, that will be having the various uniform and gradient temperature definition to be given, and again we'll be having the winds which are acting in from the both the directions. Then you have the earthquake load, and third you have the other loads, right? All right. Over here we cannot consider the wet concrete load just because we are considering this as the segment are precasted. Okay, so there is no concrete layer on the top of the structure unless for you have a slab that is there, right? So in the modeling we won't be considering that particular load for the same. Okay, so we are just placing the load of the varying course that is there in terms of load. Okay, so whenever you have the composite bridges where you have the sequence of the load as such, where you are after the casting of your girder, your dead load of the slab would be, your wet concreting would be done. At that point we need to consider with the wet concrete load. Over here we won't be considering that. Okay, if it is a cast in situ, then in that respect cast in situ box, then at that point you can consider in terms of load. So since we have assumed that it is a precasted segment, it is already being casted at a site, so that is the reason why we have not considered the wet concrete load in terms of load over here. All right. All right, so this was one of the query. I will just take the queries at the end. All right, so this is about assignment of the loads. Okay, so I was assigning with the varying course. Let's give the load case to be SIDL. Now you can apply the intensity. So since you know the intensity and the area, you can just multiply those and arrive at the intensity. So I'm just assuming this as minus 16.5. Okay, to be the varying course intensity throughout my entire structure. So I'll just use again with the selection of the elements. So priority to applying any of the command, you just have to make sure that you are selecting with the elements. So you can just select with the elements again, and you can click on apply. Okay, so that particular load will get applied. Okay, similarly you can go on assignment of the various elemental loads. Okay, so you can also assign for your crash barrier. So you can just choose with the SIDL crash barrier. Okay, so again type would be same. Over here, since your crash barrier would create the eccentricity, just because it will also induce certain rotation, or it will also create certain bending moment, certain torsion with respect to the eccentricity, right? So with that you can just provide the eccentricity for the applied load. So for the crash barrier I'm telling. So over here you can directly set to this to offset into the local Y direction. You need to apply the load, and now you can just set the load value as minus, let's say I'm assuming the intensity as minus 8 kilonewton per meter for your running UDL crash barrier load. Again for the selection you need to apply this. So I'm using this select all option so that all the elements would be selected. So I'll hit on apply. Okay. Similarly, once sorry, you need to provide with the eccentricity as well. Okay. So eccentricity is with respect to this point. So we'll be assigning with reference to this point. So I'm just giving this as minus 4.25. That's it. Okay, so let's try to select with this. Okay, so I'll click on apply. Okay. So now once this would be my crash barrier load. That is your uniform load that I have given. Similarly, I will just change the direction of the eccentricity towards positive, right? So I just hit on apply. Okay. So this is how you can assign the various elemental load. So these are all the imposed load which I am assigning. Similarly, you can go on assigning with the different elemental loads that in terms of the imposed load we can assign. Okay. So let me try to move forward. Yeah. All right. This is about this. Now we'll move towards applying a pre-stress load application. How we can define with the pre-stress load definition. Okay. So you can go to load. Can go to this moving temperature pre-stress definition. Okay. Then we'll just set the tendon property initially. So you can go to add, okay, with the tendon property. So it is we need to define the type of tendon. Let's say I'm giving the name over here as tendon. Tendon type to be internal post tension. Okay. Let's say for internal post tension I'm assuming. And the material I'll be selecting. So I'm just selecting the second material, that FE540. Now here you will be given with the option either to enter with the total tendon area, or depending upon the anchorage system, you will be giving the anchorage standard strand diameter and the number of strands required. So you can use this 3-dot button for the same. So let's say I'm using 19T13. So I'll just use this 12.7 mm as my standard strand dia, and let's say I'm anchorage system is of 19T13. So I'll give the number of strands to be 90. So I hit on OK. Automatically program will take the required total tendon area, right? So now again I will just change this to I will enter the duct diameter, right? So in order to consider the net cross sectional concrete for your stress calculations at the top and the bottom, so we automatically program will consider with the standard deduction of this duct dia. Okay, so that is the reason why we need to provide the duct diameter in the modeling. Now you can also set the relaxation coefficient calculation, loss calculation due to relaxation, right? So again you can provide the ultimate strength and the yield strength values, right? And the friction factors could be assigned, the length and the curvature for your instantaneous loss calculation due to friction. So you can just enter those based on the type of sheathing material in contact with the tendon and the concrete. Again, you can give the anchorage slip value and the bond type. Either it is a bonded type of tendon or it is an unbonded tendon. So I'll just add up this. Let me try to. Yeah, it will be okay. So just add up this one tendon material property tab. Okay. Now, second definition with respect to the tendon is inputting of the profiles. Okay. So you can import the profile or else you can manually enter them. Okay. So once yeah, so I'll just enlighten what are all the different options that are there. Either you can directly go with the standard modules that are there, right? So you can directly go to this PSC bridge option. Over here also there is tendon template. So accordingly you can just choose this standard set of elements to be where your tendon needs to be inputted. So let's say if you are choosing with this all the elements, so you can directly hit on add. So now you can, from the different tendon standard set of tendon template, you can just choose the shape of the tendon, either it is a straight or the curve type, both in plan. If you have a plan bending or the plan curvature, accordingly you can just try to give the begin and the end dimension accordingly. Okay. So let me try to show you other methods as well, how we can do that. So, oh yeah, the second one is with respect to the load. over here you can directly set the tendon profile. You can hit on add. Yeah. So now here you can directly set with, let's try to create few of the tendon profiles. For example, let's say I'm creating a profile of A1. I'll just give the name as A1 L1. So over here I'll be having a 4 level of tendons from this side and 4 level of tendons from this side. Okay, in total 8 tendons would be there. Okay, so I'm just assigning the tendon property to be as tendon, which I have previously defined. Now program will automatically consider those assigned element which you have selected. Okay, so in actual where your tendon is going to start. Okay, so if you have certain debonded length, again accordingly you can just try to simulate them accordingly just by ignoring certain elements. Now you can just set the input type as 2D or 3D and the curve type to be spline or the round, right? So I'm just selecting as 3D so that accordingly I can enter the XYZ coordinate of your tendon, right? Similarly, you can just select this curve type to be either spline or round type, okay? Then, all right. So now once you choose this, let me try to choose with the round type. Now you have the option either to go on inputting the table coordinates, or else you can directly copy paste the coordinates from the Microsoft Excel as well directly. Okay, so I have already worked out those Excel coordinates with me, right, for this typical example. So if you have already table coordinates as such, let's say these are all my tendon coordinates, okay, with respect to 40 meter span. Okay, so now once you have already prepared this Excel sheet, then you can directly select those coordinates. So I'm just selecting the very first tendon cable coordinates. So you can copy this. Make sure that whenever you're trying to copy the coordinates, the unit system has to be compatible. Both the system has to be same. So this all the coordinates are mm. So just copy this and I'll just paste it over here. So that automatically the profile will be taken by the program. So at any point of time, if you wish to enter the coordinates only the halfway, you can also do that and make the tendon to be symmetric using this make symmetric tendon option. Then you have the profile insertion point to be given. So where you can just set the point or the starting point of tendon where your actual tendon will start, right? So I'm just giving you the point as 1 so that automatically the profile will be beginning from this particular position. So I'll hit on again. If you observe, we have one more definition to be given. So once you enter this profile insertion point, you'll be setting in the rotation angle. Okay, so the rotation angle is for your with respect to, since if you observe, this is the web is inclined with respect to the vertical. That angle with that respect, you need to also rotate your tendon, whatever the inclination which we have. Okay, so I'm just giving over here as minus 11.31. Yeah, over here I click on apply, so it should be anti-clockwise, or it should be negative. Yeah, so anti-clockwise rotation you need to provide, so you can click on apply, right? So in this way you need to enter the cable, right? So this is the left cable which I have entered. Now similarly you can go on adding with the different cables for the same, right? So you can just copy all the tendon coordinates from the Excel sheet, entire Excel sheet one by one to this particular coordinates. You can just copy paste the coordinates into this particular tab and make the assignment of the point, and you can click on hit on apply, right? Likewise you can go on creating with such cases, right? All right, so let me try to go to next step. So I'll just this, so I'll close this. I'll just define with the one tendon. I'll be opening a model where I have actually defined all the tendon profiles. Once you have done with all the profiles, so let me try to open one model where I have created all the profiles over here. Yeah. So once you input this, let me try to move on till then. Over here, you can directly set this to pre-stress, the load case to be pre-stress. Then over here, you can directly set the groups. Since I am assuming that it is a sequential pre-stressing, so my first level coordinates will be stressed. First level tendon will be stressed, and secondly, my the end coordinates or the end cables will be stressed in the PS2 group. Again in this PS3, again the mid level and the fourth level. So this will how my construction sequence will follow, or the stressing sequence will follow, right? Yeah, over here, let me try to focus those all the cables. So now if you observe this, so these are the entire cables which we have. This is your A1 will denote the first level of stressing, A4 will denote the second level of stressing, A2 will denote the third level of stressing, and similarly the A3. Okay, so likewise we'll adopt the pre-stressing sequence. Now let's move towards how we can apply with the pre-stressing load onto this structure, onto the cables. Okay, so you can go to load. This is the very third definition which we'll be giving. So we'll just give to temperature pre-stress. We'll go to tendon pre-stress. Now you can directly enter with this definition. So over here you can directly choose with the pre-stress. You can just choose the PS1. Now you can just set only the cables at the first level, that is your A1 left and A1 right, that needs to be stressed, right? And once you have selected those tendons, so you can provide the jacking stress value. Either it is one end jacking, either it is both end jacking, or it is only the end jacking. So in terms of stress or the force, you can very well specify those parameters. Like if you are providing with the stress value, accordingly you can enter the stress either from beginning or the end or from the both. Okay, or else you can also convert into the force value and accordingly enter as per the user's choice or the engineer's choice, right? Okay, so now I'm trying to enter over here the value as 1395 MPa. Let's say I'm generally considering as 0.75% of the ultimate. 1395 MPa, let's say. Now once you have added this, so you can click on add. Alright, so it's already added. So you can just try to add or modify with the certain respect. So once likewise, like say suppose you have already added this, now you can just go on adding with the different cables as well, right? So since it is already added, so I'll just quickly show you what are all the different pre-stressing loads we have and what is the pre-stressing sequence that is being there, right? So this is how which will be giving, or the definition which have already been given. Okay, so this is for your A2L, this is for your ATL, A3L and left right both, and this is for the A4 level. Okay, so this is how we can directly give with the tendon and the cable input. Let's move towards the temperature definition. So over here you can also assign the various temperature loads. Okay, so you can also give the temperature, uniform temperature in terms of the elemental temperature. Okay, so you can also choose this temperature rise condition and enter the value of the temperature. Let's say I have a 40 degree. I'm assuming that it is a 40 degree rise and fall for both the case. So if it is the rise, you can click on directly choose with elemental rise, click on apply. Similarly, you can just choose the fall case and you can just provide this as negative temperature, final negative temperature. You can click on apply and just click on apply, right? Now coming to the non-linear temperature definition as per your code. So you can also enter those as per the codal requirement. The non-linear temperature could also be entered. So you can enter this in terms of the beam section temperature, as the code suggests to incorporate the non-linear temperature with respect to the girder section which is changing as per the depth. So we will be considering with such typical variation as per the recommended by IRC 6, which we'll be considering in today's example as well. Okay. So in this, we'll be considering these positive temperature differences, and we'll see how we can enter with the reverse temperature differences as well, right? So we have different temperature variations along the different depths. So we'll see how we can incorporate that. So yeah, so coming to this definition, we'll be choosing over here as the load case initially. Let's say for positive temperature case, which will be giving. Then you can just select from the standard PSC section. Okay. Over here also you can just tell the program to calculate the effective width as per the section. So program will automatically take from the section itself, right? So now over here you can just assign the temperatures from different level and what is the variation for the different depths of temperature. Let's say from 0 to 150. Okay, so from 0 to 150. So from this, from 0 by reference, I mean just I have given the top reference. Okay, so that temperature would be assigned from the top position, right? So that is a reference line, or else you can also give that from the bottom reference. Okay, so that is all the user choice. Now once you give this, so now you can just follow this particular criteria. Now you can just go on inputting. So at 0 I have a temperature of 17.8, and at 150 level, just because my depth is not exceeding, my depth is exceeding 0.5, I have to consider with the 0.15 meter. So accordingly I can enter the 4 degree, right? So I'm entering this as 17.8 and this is to be as 4 degree, right? So I will click on add. Now again I can go on adding the H1 and H2 on the similar lines and the respective change of temperature variation, that is now is from 4 to 0, right? So I can enter T1 as 4 and T2 to be 0, right? Click on add, right? Third is your depth. So again you can enter the depth accordingly, right? So you can either enter the H3 from this particular depth, or also you can enter from the bottom itself, just by choosing the reference axis. So I'm just choosing over here as 0 and in positive direction 150. And again the change of variation of the temperature is from 2.1 to 0. So accordingly you can enter this as 2.1 to 0. You can click on add. So once you have added all this temperature, you can select the elements and you can hit and apply the temperature gradient loads. Alright. So similar lines you have to add up with the negative temperature differences as well, right? All right, so let's move towards the construction stage definition, how the construction sequence could be defined in this program. Okay, so let's try go towards the construction stage definition. So first of all, let's try to assign with the structure group. We just have assigned this structure group. Okay, so what can be done is you can directly select the elements that needs to be categorized. So over here you can use either select all option, right? So that all the elements will be selected. So I'm just displaying certain things. Okay, so after this we'll move towards the construction stage definition. Okay, so regarding the grouping, you can assign the structure group once you have selected the respective elements. You can just drag and drop again in the similar way which we have done for the section geometry change. Okay, now you can just go to define construction stage. So over here you can add up the define construction stage with the very first stage. So we'll add up this, right? So we'll follow the sequence as such, wherein your first span is launched at the age of 21 days. Then second sequence will follow in the second construction stage. You will follow that the spans are pre-stressed, and third in the third construction stage will follow that the application of here all the superimposed loads or the other serviceable loads that needs to be applied. Okay, all right. So let's try to define the very first construction stage, that is CS1. Okay, I'll activate this CS1 at the age of duration to be 14 days. So it means that your construction stage duration is going to last for 14 days, right from beginning of the very first day to the very last day. So that will last for the that CS1 is going to last for the 14 days. Now you have the different tabs to be activated. You have like elemental tab, boundary tab, and the load definition to be given. So okay, so in the element tab it will always follow the structure group. In the boundary group you will always follow the support definition that needs to be activated, and in the third group under the load group all the load group will be requiring to be activated and deactivated on the similar lines, right? So let's talk about the structure group, that is the elemental activation. So over here I'm assuming that my span is casted at an age of 21 days. So whenever my first day would be my first construction sequence would be activated, my first span will be launched at an age of 21 days. So I just add up this structure group having the age or the maturity of 21 days at the very first start of this construction stage 1. So it means that the girder will undergo at the end of the construction stage, the entire age of the girder would be 21 plus 14 days when the first stage is completed, right? It means that at the end of CS1 the girder will undergo, or girder will be of 35 age days duration, right? So this is how it works. This is age is different and duration is different. So this duration is something that the time lasts from start of the activity to the end of the activity. So the age or the activation age of the member element is with reference to the age of the concrete element prior to the beginning of the sequence or beginning of the start of the construction stage. Okay. So now I'll just add up this over here, coming to the next boundary tab. So it means that once your structure is activated, all your supports will be activated into the deform position. Okay, so I'm activating all the supports. Okay, and third, you will be activating only with the self-weight at the very first day. Okay, so you just have to click on add under this activation tab. Okay, so I'm just adding only for now the self-weight case. I'll click on apply. So one construction stage will get added up in the background. Now similarly you will go on defining with the CS2, that is for your second construction stage definition, wherein your pre-stressing activity would be carried out. So here you just no need to activate for the rest of the part, only you can directly hit on this particular load tab, wherein you can additionally create the load sequence or the load parts. Okay. So for now, since as said earlier, the full level of tendons will be stressed with reference to the time duration. So we have PS1, PS2, PS3 and PS4, right? So those will be stressed sequentially. So those needs to be activated one by one, right? So for now we have, if you activate, for now we just have the first and the last definition. In order to create the intermediate step, we need to add up few additional steps as well. So this CS2 is going to last only for the single day. So we'll carry out all the pre-stressing activity in a single day. Okay, in the interval of, let's say, for 6 hours interval. So I'll just give this, I just add up this in terms of days, right? So I'll just convert the 6 hours in terms of days. So I just add up randomly few of the additional steps. Now once you come to load, so you can just select the PS1 that is activated not directly on the first instance, but let's say for a 6 hour interval. So you can add up this point to duration and you can click on add. Similarly for your rest of the stages, so you can add up. Right, so you can hit on apply. And third, you just have the serviceable loads that is for your long-term consideration. So I'll enter the duration to be 10,000 days. Okay. So this is generally to keep or see the creep sinkage deformation at the end of the stage. Sorry. Wherein you can activate under the load tab the SIDL load. So you can just add this SIDL loads. Okay. So I'll just click on OK. All right. So I'll just close this. Okay. So now if you check, yeah, so this will be my CS1. Let me try to focus all the construction sequence or all the construction stages itself. Okay, so in the first stage, only my span is cast, my entire span is casted, and my supports are activated, right? So when I come to CS2, my all the pre-stressing activity has been completed. At the end of the CS2, all my pre-stressing stands are appearing now. And in the third stage, all my other loads that are serviceable load that will be coming onto the structure that will be activated. Okay, so this is how the sequence would be. So this is just to show you how differently we can consider with the construction sequence. Right. Now let's move towards the definition of the moving load or yeah, live load definition. Okay. So for that, you can go to this moving load definition over here. So you can just go to this moving load. Now you can just select the code over here as India again. Now again, it is a three-step process to complete all your live load definition. Okay. So first we'll be assigning with the traffic line lanes. Okay. So traffic line lane will follow the eccentricity or the CG of the vehicle to be placed. So I'll just hit on add. So I'll add up one line lane, traffic line lane. Okay. So I'll just give the name to be 70R, and you just provide the eccentricity as 1.155. So again, eccentricity needs to be worked out with reference to the code. Okay, so that is nothing but the placement of the vehicle with reference to the initial position. So I will be setting this line element as my reference line. With respect to this reference line, my eccentricity or my CG of the vehicle will be placed, which is nothing but your eccentricity. And over you can specify the span length. Okay. And now over here you can just select the vehicular load distribution type to be lane element. And where you can just give the moving traffic direction, either it is a one way or it is a both way or it is a backward traffic. You can just select first and the last point. Okay, so once you define this, program will automatically place the reference position of the vehicle, okay, with respect to the assigned eccentricity. Okay. So likewise, you can go on adding the different lanes. Okay, similarly for the class A, the respective lanes could be added up. Okay, so I'm not going to add all the lanes. So I'll just open the model directly. So second one is for your vehicular definition. Okay, so in the vehicular definition, you can add the standard set of vehicles. All right, so I'll add up one more lane over here for the class A vehicle. So I just add up this. We'll just add one, just for your reference, I'll add one more vehicle. I'll just place the eccentricity over here as, okay, so I'll just assume the eccentricity at 2.45 meter from the mid. Okay. Over here we'll be having, since the clear carriageway width is 7.5, so our design number of lane purposes would be 2. Okay, so as per the IRC 6, so in critical combination, if you check, we'll be having one lane of both 2 lanes of class A and 1 lane of class 70R, right? So you need to place both the two lanes of class A accordingly with respect to the code, right? So I'm just trying to show you only the one lane, okay? So you can just select the first and the last node. So you can hit on apply. Similarly, the second load will be placed with reference to the reference position. Okay. So now let's come to standard vehicle definition. So you can just move towards vehicles. So here you can click on add standard. Here you can select with reference to the as per IRS or IRC 6, either bridge loading or the train loading. So there are some standard set of loads that are already defined, integrated. You just need to select the load standard set of train loads or the wheel loads. Okay. So I'm just selecting with the class 70R and class A vehicle. So I'm just I've just added two loads or two vehicular loads. So I'll close this. Now I'll go on to forming the moving load definition. So you just add up this. So now over here you can add up the two lanes of class A or one lane of class 70R. So it is just to create your load cases. So I'm just adding one lane of class 70R. Okay. Now over here you can go on adding with the subload cases. So I'll add up this. Now over here you can specify the minimum and the maximum criteria. So you can add up the minimum number of load placings and the maximum number of load placings. So accordingly you can select the vehicle class, either it is 70R or it is a class A, right? So you can give the class 70R and select the respective lanes. Okay. So now if it is a case where you have the two lanes of class A, then you can give the respective minimum to be as 1, minimum number of loaded lanes to be 1, and maximum lanes to be as 2, right? So this would be your case which you would be considering. Right? Then again you have the class A, choose the placement of the vehicle, and you can just select both the lanes which are there for the class A. Right? So you can add up accordingly. So for now I am just considering with only for the 70R. The rest can be done at the end. Okay, so I'm just adding only one lane of class 70R, okay, in the consideration. So I can just hit on OK. All right. So now this completes my moving load definitions. Likewise, you have to go on adding with different load cases and load combinations accordingly. Let me try to open a completed file over here where I have defined all the reference lanes, that is for one class 70R and two lanes for class A, right? So where I have formed the different combinations. So one is for your class 70R, all right, where I have added only one class 70R lane, and secondly you have considered with the class A definition where both the lanes have been loaded. Yeah, so over here I have given the criteria as two lanes of class A to be added. Okay, so you can likewise you can add up for the same. Okay, so now once you have completed with the moving load definition, so you can just give certain control parameters, analysis control parameters. So you can just go to analysis. Over here you can just set to construction stage. Now over here also you can just try to create few of the load cases to be distinguished from the dead load. So since a dead load being your primary load onto the structure, program automatically clubs rest of the dead load in order to output into the construction stages. So it will all the your superimposed dead loads and everything will be clubbed under the CS load. But if you wanted to extract the results for different cases separately, so you can just add up over here. Now you can just give the in terms of the erection loads you can add up. So you can hit on OK. So if you wanted to, it is in just case if you wanted to check for your other CS load. If you wanted to check into the construction stages what could be the effect, you can assign them in terms of separate erection loads. So you can add, so you just select this as constant. So if you want the beam section property to be changed with respect to the tendon, then you can just hit on this option, or else you can just make this as to be constant. Okay, so you just click on OK. Also you can just set the moving load analysis control. So over here you can just set either you want the normal reactions, or else you want normal plus concurrent force reactions stresses results to be obtained. So accordingly you can just classify, or you can just reorganize your output information to be desired. Also you need to set the impact factor calculation, that is the bridge type impact factor calculation, either with steel or RC. Okay, you can just select with RC, since a program will automatically take the impact factor calculation based on the type of bridge, type of material of the bridge. Okay, so you can just hit on OK. All right. All right. So once you have completed, so you can just perform the analysis. So you can just go to analysis and just hit on perform analysis. Okay, so now once my analysis is completed, so you can move on to defining our interpretation part. So the interpretation part is quite easy, so you can directly move on towards the result part. So initially you can go on forming with the load combinations. So you can just go to load combinations over here, and you can just go to this concrete design tab. So either you can manually create all the ULS and the SLS combinations manually, or else you can also use this auto generation feature. So using this auto generation command, you can directly set the codal respect. So program will automatically create all the load combinations that are required as per the IRC 6 limit state design, right? So you can just give the code over here as IRC 6. So I'll click on OK. Alright, so if you check all the possible load combinations, so more than 50 load combinations the program has created for now, right? So it will add up all your static loads as well as your moving load in account, okay, for all your strength and serviceability conditions. Alright, so those will be created by the program automatically. I'll just close this. Now if you wanted to check for different results such as your reaction, deformation and the forces and the stresses, which could be checked from this particular tab. So you can just see the reactions under this tab. So with the different construction sequence and the different construction stages, you can also check for the stages itself. Yeah. So let me try to run the results for your stage model which I have created. So it's analyzing yet. Yeah. So let's go to results part. Okay, so you can just check with the reactions and the deformation results from over here. With the stage wise result also you can check. That is for your like for dead load and other cases you can check the reactions, right? Also you can hit on this legend for to see into the list particular tab, the legend form. Also you can also check for your tendon primary, the deformations due to tendon primary and everything you can also check. So you can check it in the stage wise how the deformed shape would be, right? Similarly with the forces, beam forces also you can check under the post TS stage, right? Or the dead load also you can check. Right, so you can evaluate the results in this respect, right? The graphical result output could be obtained from over here. Also, you can also check from the result table itself. Okay, so if you want the tabular results in one go, so you can just go to this result table, and now you can just hit on this beam tab, force and stress, right? So now you can directly choose which load case you want the results and for which particular part. Accordingly, you can just categorize the requirement or sort the requirement as per the need. Okay? You can get the result into this particular tabular form. Also, you can export this to Excel since it's very compatible with the Excel. Results could be also be taken to the Excel itself, right? Yeah, so now this is all about the checking of the results and with respect to the beam forces, moment axial forces and the stresses, right? Stresses could also be checked for the top and bottom stresses could also be checked again. So now let me go towards the design part without much delay. So you can directly go to this PSC tab. Now you can directly hit on this IRC 112. So we'll be using the IRC 112 for our design part. So let me try to go with this. Yeah. So now you can directly go to this IRC 112. Now you can just set the parameters initially. Okay, so with this IRC, you can just give the certain parameters to be considered. That is the design parameters. Just for ULS and SLS, you can consider. So I'm just using this select all option. So in order that the ultimate and the serviceable limit state could be considered. So I want the output for both ULS as well as ULS or SLS. So accordingly, you can select those parameters. So just click on OK. You can also give the PSC design material. Okay. So here you can just modify the material data, or you can directly give the compressive strength of the concrete as required. Right. So I'm just using over here as IRC again. Okay, so just using as M40, rebar to be M500, let's say, and just click on modify. Right. Okay, let me go through this. Yeah. So once you have modified the material, you can go to this design position. So you can just set the design position where you need to obtain the results. So if you wanted to obtain the results for the entire structure, you can just select the sections accordingly. Okay. So let me try to select only with the single section, only with the mid element. I'm just trying to design the mid element itself because it will give me quickly. So I'm just worried about the critical result to be critical element to be designed. So I can just select the mid element, any random mid element for now, just to show how you can obtain the results. Similarly, for the output position, you can just set the element which we need to design. Okay. After this, you can just set the serviceability load combination type. Okay. So let me first try to create the load combinations. I think it's not created over here. Okay. So I will come to PSC. Accordingly, program will categorize the serviceability load combinations as per for the Cauchy permanent, frequent, and characteristic. Okay. All right. So after this, you can just hit on this perform design. So once all the definitions are given, you can directly go on into the design part. Okay. So with all the combinations, program will perform all the iterations and give you, with all the envelope cases, program will give you the critical results. Okay. So once the design is completed, so we have more than 50 number of load combinations, right, for all the cases. Let me try to get you the final report. Since after the design is completed, you can directly head to the Excel report generation, wherein you can directly hit on this Excel report. So I'll quickly show you the design report for sample. So it will take time for the design. So just show you the result which are already there with me. So over here you can just check the final design report which will be outputted from the program. So this is how the report would be, like all your design information or the input information as per the clause, as per the code will be specified and displayed in the report with all the partial safety factors that it is considering, right? All the sectional information that is giving. Then you have all the tendon profile information and all the strength and area that is there, right? Then program will perform the design as per the code I112 with all the codal formulations, everything that is indicated against the clause also over here. You can just check. So the program will perform different iterations to check with your neutral axis depth. So it will find out all your required moment of resistance of the section and everything it will check for, right? So those all the stress checks is done by the program. So this is quite a brief report that you'll be obtaining at the end, right? So you can go through this particular report for a complete brief report. Similarly for the shear and torsion. Similarly, it will also check for your tendon stress. All right. Yeah, I think, yeah. So this is a brief summary or brief aspects of modeling the box girder bridges into the civil. Okay. So I think now I can take your queries, question and answers. We can do for more 5 to 10 minutes. Okay. So if you have any questions, you can ask. There were a few questions that were asked initially. I will just try to emphasize on that. Okay, so how we can define this box girder section, solid box section? Okay, so coming to this question. Okay, again for the solid box, its definition is same. So over here also you can go to structure tab, sorry, properties tab. You can go to section properties. The same way which I have created the diaphragm section over here. Also you can just try to create the same, right? So over here also you can just try to minimize this dimension. For now I'll just consider the inner box as 0.5, 0.5. So what you can do is you can just try to give with the minimum dimension, say 0.1, 0.1. So that will also work as a more or less a solid box section only. Okay. All right. So any other questions you have? So there was one of the question that the local axis of the support will be different from the entire structure. Yeah, the direction of the local axis which you are entering the stiffness values, so that is different from the global axis, as I already discussed about. Okay, so these global directions are different. The stiffnesses has to be entered into the local direction of the elastic link only. Okay, so all right, I'll just repeat one more thing. So we are having a problem in placing the second lane of class A lane. All right, so I'll just try to demonstrate how we can do that. All right, so I'll just come to this load tab. Over here, you can just set the moving load. over here you can just try to come to this particular point. Now you can just add up this. Over here you can just try to add up. Once you have already defined the first lane of class A, now what else you can do is you can just try to place the vehicle just by specifying the eccentricity in the either direction. Okay, so just make ensure that when placing the vehicle for the class A, just maintain the minimum distances as per the code, and you can just assign this particular as reference line and give it the negative eccentricity. So positive eccentricity will work as per for the positive direction of the traffic, and negative direction again will work for your in the left hand side direction of the traffic. Okay, so just try to make ensure that the eccentricity is correctly entered. So you can just place the vehicle into the right hand or the left hand side direction of the structure. Okay. So okay, so there is one question: how to define the hollow portion into the diaphragm? Okay, so the hollow diaphragm section you can create yeah, in the similar manner so what we have discussed. It's all about the section property definition. All right, I'll just focus one more thing over here. So what can be done is, since we have created this particular section geometry just with reference to this particular bitmap image, there is also one option available with us as PSC value type, wherein any of the irregular section or the cross-sectional geometry which we have created using AutoCAD, you can just try to import that using as SPC tool, that is as SPC file. Here also you can just try to give the path for the same. So any of the irregular section also you can just try to model over here, either it is a hollow or it is a full solid section. So those will be very well be imported. So if you want to wish to manually create from this particular definition, just try to make the dimensions over here as to be minimum. Accordingly, you can just try to modify the concrete dimensions as per the required. Okay, so accordingly either you can make it fully solid or else you can make the hollow as well as what we have created over here, right? So you can just try to create this in similar fashion. That is how we can see the principal stress of a particular, yeah, the stresses, contours and everything is again the interpretation part again over here. So you can just come down to results tab over here, and you can just check for the principles, the maximum stresses that are coming, right? So again, you can check for different load cases and combinations over here. So you can just check this, right? Similarly, you can just turn on this legend as well, right? So now you can observe the stress diagrams. So both for the top position as well as the bottom position you can observe. Right. So the contours, if you wish to check, you can also turn on this contours as well. Stress contours. So there is also option for beam stresses. Okay, so you can just go to this beam stresses. So beam diagrams will specifically give you the diagrams, and also you can check for your beam stress diagrams as well. Let's try to check for the dead load. Yeah. Also you can check for the dead load. Okay, so it will also give you into contour form or the beam diagram form. So again, those could also be interpreted as well. For this, what is the maximum tensile strength of the tendon which we have given? For here, I have entered as 1860 MPa for this consideration. For this example, I have considered with this. The ultimate strength which I have considered. Yeah, so again, there is the last one more question over there. 7 in 1 cable group tensile strength. Yeah. So if you talk about this particular tendon property definition, okay. So we have entered a total tendon area, which means that we have given the entire strands considering all the only all the cables, right? So that will give you the number of the strength which is considered for that particular property. So the number of cables, number of property would be assigned. Let's say we have two cables. Okay, so the two cables will assign with the different property. Like if you have a similar property, then again you can assign those. Okay, so it is not a common for all the tendons. It is for the individual tendon or the individual cable. Yeah, so there is one more question. Want to know about the ultimate strength of the concrete beam deviators, deviator enforcement. Okay, so all right, so those could also be modeled. Okay, what can be done is either you can go with the solid modeling. Okay, so you have to model those deviators again to check with the stresses. All right, so in order to check for your anchorage results, so accordingly you need to formulate that. Since what we have done for now is just we have modeled the reinforcement. We have just modeled the tendons or the cables, and we have just applied the load or the pre-stressing load. But in order to check with that, so accordingly you need to consider with the modeling. Yeah, so that is what we need to do, like for the anchor pocket reinforcement behavior, that's what I'm talking about. So the typical behavior, we won't be getting into the beam element. Okay, so we have to go look for the higher elements modeling where your interface and everything will be considered. So that is again a different thing which we need to consider. But for now, for the analysis and the design part is concerned, we can directly just model those in terms of load or the pre-stress loads. Yeah, all right. So I believe most of the queries are there. Most of the questions are there, I guess, have been addressed. So again, yeah, so want to know the blister anti-sparring reinforcement strength. Yeah, again, as I talked, over here you'll be getting the stresses, the ultimate stresses at the, as we have simulated the construction sequence as such. So you'll be getting the stresses at the end point, like for the 10,000 beds which we have considered, right? So for that you'll be getting the top and the bottom stresses. So we wanted to check what is the blister, like this ultimate strength of the blister which is undergoing, then accordingly you have to go with the higher elements formulation. That is for, then you have to model with the solid modeling, and then you, in that you have to give with the pre-stressing and everything. At that point you can just check the influence of the stresses transfer, where we cannot get those into the beam element. Okay, so that cannot be simulated in the beam element, as I said. So you have to go with the higher order elements such as your solid model, right? All right, so I think we have done with this. So for further queries, what can be done is you can just try to write more onto this. Okay. All right, so I believe most of the questions are addressed. All right, thank you everyone for attending. So for further queries, then do visit globalsupport.midasuser.com, where you can send us your queries online. So we'll be addressing for the same. Okay. So yeah. Thank you everyone for once again. I am closing the session now. Thank you.